Okay, tell your friends that attend lectures sincerely. Otherwise, a strict action will be initiated for them. And then they will have to pay for that fees. So just do it sincerely. Also, do the assignments and test sincerely. Okay. Okay. So we were discussing about revision. Okay, about what is the basics of VHDL that we were discussing, and in continuation with that, let us discuss some more things. So, in the last session, we discussed one more time different types in a VHDL. Okay, so now in today's session, we are going to discuss about operators in a VHDL. So, in a actually, there are basic six classes of operators, but there we add one more class in this operator type, that is a miscellaneous operators. So overall, there are seven different operator types in a VHDL. Okay, so here whatever are these operators that are listed, okay, with increasing here these operators that are listed with the increasing precedence or the highest precedence. Okay, so that means this will be these miscellaneous operators that will be executed first, after that multiplying operators, then unary operators, and so on. Okay, so that means if we are adding a brackets, okay, so if we are brackets are there, then only those operators that will be executed first. Otherwise, in this precedence, that means from the this is the lowest, having lowest precedence, and this is the highest. In that way, it will be get executed. Okay. So the first type of operator, that is a logical operator. So in that, we have different operators which can perform logic functions. Okay, that is a and, then or, NAND, NOR, XOR, and XNOR. These are the logical operators. Then relational operators, that is a equal to, then not equal to, less than equal to, greater than, and greater than equal to. Okay, so these are the different relational operators. Then shift operators, that is SLL, that is a shift left, then shift right logical, then shift left arithmetic, shift right arithmetic, rotate left, and rotate right. These are the shift operators. Then addition operators, that is a plus, minus, and ampersand that is used for the concatenation. So these are the addition operators. Then unary operators, that is a plus, minus, multiplying operator, that is a multiplication. So this asterisk, then backslash, that is for division, then modulus, mod for modulus, and rem, that is for the remainder. Okay, so these are the operators, multiplying operators, and then star, that is for the exponentiation, then abs, that is for absolute value, and not for logic negation. Okay, so these operations, that means exponentiation, then abs, that is to find getting the absolute value, and not, okay, that is the logical negation. These are operations that are performed first. Okay, so as it is having the highest precedence level, so this will be performed uh, first. Okay, so now let us see one by one all these operators. Okay, so the logical operators, that are or, NAND, NOR, XOR, and XNOR. Okay, so these are the logical operations that are available in the VHDL. Okay, so here this logical operations that will be accepting operands which will be of the type bit, then boolean, then std underscore logic or std underscore u logic types and their vectors. Okay, only these operands types that will be accepted when we are considering a logical operator. म्हणजे तुमचं कुठलंही ऑपरँड जे असणार आहे ते कुठल्या टाईप मधलं पाहिजे, एक तर ते बिट पाहिजे किंवा बुलियन पाहिजे. Then it may be std underscore logic or std underscore u logic type. Okay, and then if the array is there, then it should be of a bit type. Okay, now again one more important thing is that operand must be of the same type and length. Okay, so that means if you are considering two operands, so both that must be of the same time and at the same time it should be of the same length. Okay, so here these examples are given. So signal a comma b, that is a bit vector. Okay, so that is the first initialization, and then signal c d e f g, these are the bits. Okay, so now here what is done, there is a assignment operator. Okay, so this is the assignment operator that is used, that is a less than equal to. So that means whatever is the expression that is assigned to a, so a is assigned to b and c. Okay, now this will give a syntax error because b is the bit vector while c is the bit. Okay, so as both are not having same length, and that is why uh, they will not be executed, or at the same time this that is of not same type, actually not length, in case of saying not length same length, but it is of not of a same type because b is a bit vector, a is also a bit vector, it is an array which is having a size that is a 6 down to 0, and c is only just a bit. Okay, so as they are not of a same time, and that is why same type, that is why it will give a error. Okay, then here d is assigned to, in a bracket, a e xor f uh, and c xor g. So first of all, this uh, expression that will be executed at the same time, this will be executed, and after result of that will be ANDed together. Okay, so that means if there is a bracket that is a present, then it will be executed first, and then after that whatever is the outside bracket that will be executed. Okay, now remember that whenever we are using an AND operator and NOR operator, we have to use a bracket. Okay, so that means parenthesis that should be used whenever we are using NAND and NOR, because they two operators that are not a associative type. Okay, and that is why whenever you are using this, so they should be uh, written in a bracket, okay, or parenthesis. Okay, so that means suppose you have the expression like a NAND b NAND c. Okay, so if you have not used any parenthesis there, so then it will give you a syntax error. But if you write it in this way, that a NAND b in a bracket and then NAND z, then it will perform a proper operation. Okay, or it errorless execution will be there. Okay, so these are the different logical operations. So here, whatever keywords that we are using for these logical operators, that is the AND for ANDing operation, OR for ORing operation, then NAND, NOR, XOR, and XOR. Okay. So these are the logical operators. Then relational operators. Okay, so relational operators, that means they give a result of a boolean type. Okay, so whatever if we are relating certain expression with any operand, then it will give a boolean result. That means it, whether it is a true or false, in that way it will give us the result. Now here again we need to remember that operands that must be of the same type and same length. Okay, so we have the different relational operators like equal to, that is a equal, that will check whether there is equality between the operands or not, or inequality, then smaller than equal to, or greater than, and greater than or equal to. So these are the different um, relational parameters. Out of that, equality and not equal to. Okay, so that means equal and not equal to, that will operate on operands of any type. Okay, but and they will give us the result that is of a Boolean type. That means either a true or a false result. But smaller than, then smaller than, or less than or equal to, then greater than and greater than or equal to, these will be operated on the operands of scalar or discrete array type, all these operators, and then result will be Boolean or a Boolean type, that is a either it is a true or false. Okay, so example of this is, suppose a signal a comma b, these are the bit vector, which is again 6 down to 0, and that means this is the array a and b, these are the array, while signal c, that is a Boolean. Okay, so then c less than equal to b, less than equal to a, that means it will check whether c is less than or equal to b, or less than or equal to e. So actually it will go from the left side. Okay, so whatever is the expression over here, this side, so that will be executed first, and then it will check. So it will check whether b is less than or equal to a first, and then it will go for the checking of c less than or equal to whatever is the expression. Okay, so this is the relational operators. Then the next type of operators, that are the adding operators. So it will have um, um, operators like a plus, minus, then uh, ampersand. Okay, so these are the characters that are used for these operators. So out of this, plus and minus, this is used for the addition and subtraction on a numeric type. Okay, so that means here whenever we are using these operators, then operand must be of the numeric type, and at the same time this ampersand, that is used for the concatenation. Okay, so here whenever we are using this concatenation operator, that means whenever we want to connect two operands with each other, that time we use ampersand. Okay, so you must have seen this whenever we executed the program for last program that we executed, that is a multiplier. Okay, add and shift multiplier. In that we concatenated 0 whenever we want to shift the numbers. Okay, so when we want to shift that addition, that time we use this concatenation operator. So this, in that concatenation operator, we can use operands, that is a array, or it may be any element type, or left side operand that will be there, and same right side operand will be also of the same type, it will be there. Okay, and the result will be whatever is the operand that on which we are doing that operation. So the same result, same type will be there for the result. So here this is the example. So here you can see that whenever we are having a numeric data type, then only we can perform this addition and subtraction operation. Okay, and then whenever we want to combine two operands, so then in that case we can use a ampersand operator. That means it is a concatenation operator. Okay. Then okay. So here there is a one more operator that I think slide is missing in this. So okay, let us discuss. That is a shift operator. Okay, so shift operator. So SLL, that means it will shift a left logical. That means suppose you have the number a is equal to 100,100. Okay, so whenever you are saying SLL a, so it will shift a number to the left. Okay, now if you are saying SLL2, okay, so that means num1 SLL2, suppose a, or a SLL2. So in that case, it will shift whatever is the number with 2 bit left. Okay. So if you have the number that is a 1, if you have the number 1 1 0 1 1. Okay. So with SLL2, what will happen? This number will get shifted to the left, okay, with uh, that is a 2 bits. Okay. So what result you will get? Now on the
number and check the number.
number is, you can't see this number. I have written over here 11011.
No,
Okay. So 110, आता तो आपण काय करतोय, SLL2 करतोय, म्हणजे 2 बिटनी लेफ्टला शिफ्ट करतोय. ओके. जेव्हा लेफ्टला शिफ्ट करतोय तेव्हा लॉजिकल ऑपरेशन करतो when it is a SLL, that means shift left logical. Okay. So on the right side it will get 0 will get added. Okay. So here it will give us the result like what? Zero, 1 1, 0 0. Okay. So that will be the result. ओके. म्हणजे इथे काय होणार आहे की तुमचा हा सगळा लेफ्टला शिफ्ट होणार आहे. सो विथ अ 2 बिट्स. सो द फर्स्ट बिट विल बी नाउ 0. Then after that it will be followed as a 1, then 1, and then on the right side it will be a 0 0. Okay. So this will be your result, that is a 0 1 1 0 0. Now if you have the expression that is a SRL2, so that means it will get shifted to the right side. So on the left side it will add a 0. So now the result will be 0 0 1 1. If it is a SLA, that means it is a shift left arithmetic. Okay. So whenever we are doing this operation, shift left arithmetic. So in that case, whatever are the vacant bits are there that are filled with the rightmost bit. Okay. So right vacant bits that will be filled in a SLA, it will be filled with the rightmost bit, while in a SRA, that is the shift right arithmetic, then left, in that case left bit will get vacant. Okay. And that bits will be filled with the leftmost bit. Okay. So that means whenever we are having a number 11011, so when we are doing an operation that is a SLA, so what it will do, it will get shifted to the left. Okay. And then the vacant bits. Okay. So 2 बिटनी तो काय होणार आहे, लेफ्टला शिफ्ट होणार आहे, म्हणजे 0 1 1 हे तुमचे पहिले 3 बिट्स येतील. ओके. कारण आपलं 5 बिट नंबर आहे. आणि उरलेले जे 2 बिट्स आहेत ते तर वेकंट झाले, तर ते कशाने फिल होणार आहेत, तर जर तुमचं राईट मोस्ट बिट होतं ते काय आहे 1 आहे, तर त्या बिटनी ते फिल होईल. ओके. सो युअर नंबर विल बी 0 1 1 1 1. Okay. In the same way, when you are saying SRA, so the number will be now here, it will get shifted towards right. So actually it will be 110 on this least significant string, and here these left bit 2 bits that will get vacant, so that will be filled with the leftmost bit. So it will 1 1 1 1 0. Okay. Then ROL, that means rotate left. So this number will get rotated. So ROL2, that means it will get rotated with the 2 bits. Okay. So what will be the result? मी जर 2 bit ने म्हटलं ROL2 म्हटलं. Okay. So that means it will get rotated with 2 bits. Okay, on the left side. So result will be now the same number if you consider. What will be result? काय येणार रिझल्ट? इट विल बी 0 1 1, कारण तो रोटेट होतोय नंबर, म्हणजेच तो काय करणार आहे, इकडचे बिट्स आहेत ते परत इकडे येणार आहे 1 1. ओके, किंवा ROR म्हटलं तर तो काय होईल, राईटला शिफ्ट होणार आहे, राईटनी रोटेट होणार आहे. सो इट विल बी 0 1 1 1 1. ओके, ऍक्च्युली सेम रिझल्ट तुम्हाला आधीसारखा वाटेल, बट ऍक्च्युली इथे काय होतोय की तो रोटेट होतोय नंबर राईटला. ठीक आहे, आणि याच्यामध्ये मात्र आपण काय करतोय, SRA मध्ये आपण शिफ्ट राईट करतोय, आणि जो वेकंट बिट्स आहेत तिथे आपण राईट मोस्टला किंवा लेफ्ट मोस्टला, म्हणजे SRA म्हणजे राईट मोस्ट बिट जो आहे तो आपण तिथे ऍड करतोय. ठीक आहे, सो इन दॅट वे दीज ऑपरेशन्स विल गेट परफॉर्म. ओके, कुणाला काही डाऊट आहे का याच्याबद्दल?
मॅम हे सगळे एकदा आणखी एकदा सांगा ना, ते काहीच नाही कळत आहे ते.
ओके, मी परत एक नंबर वेगळा घेते. ठीक आहे, 0 0 1 0 1 0 1 0. ठीक आहे. ओके, आता मी SLL असं म्हटलं, म्हणजेच काय आहे, माझी इन्स्ट्रक्शन काय आहे की शिफ्ट लॉजिकल लेफ्ट. ओके, शिफ्ट लेफ्ट लॉजिकल, ऍक्च्युली शिफ्ट लेफ्ट लॉजिकल. इथे तुम्ही जर त्याच्या पुढे एखादा नंबर ऍड केला तर तो काय होणार आहे, तेवढ्या बिटनी तुमचा ते शिफ्ट होईल. ठीक आहे, म्हणजे मी जर SLL 2 म्हटलं तर माझा नंबर हा काय होणार आहे की 2 बिटनी लेफ्टला शिफ्ट होणार आहे. पण हे लॉजिकल ऑपरेशन आहे, तर इन दॅट केस ज्या माझ्या पोझिशन, म्हणजे जे माझे बिट पोझिशन वेकंट होणार आहे तिथे मी काय ऍड करेन, तिथे 0 ऍड होणार आहे. ठीक आहे, म्हणजे आता जर हे ऑपरेशन तुम्हाला करायचं असेल SLL2, तर तो नंबर काय होणार आहे, लेफ्टला शिफ्ट होणार आहे, म्हणजे नंबर येईल 1. ओके, 2 बिटनी शिफ्ट होत आहे, म्हणजे हा इथून पुढे जे नंबर्स आहेत ते लेफ्टला शिफ्ट होतील, 1 0 1 0. आणि आता इकडचे जे बिट्स आहेत ते काय झालं, वेकंट झाले. ओके, सो इथे 0 0 ऍड. ओके, सो दिस विल बी युअर नंबर रिझल्ट. ओके, काय झालं, हे लेफ्टला शिफ्ट झालं आणि ज्या वेकंट पोझिशन झाल्या होत्या त्याच्यामध्ये 0 0 ऍड झालं. आता तुम्ही SRL म्हटलं, SRL2 म्हटलं तर तो काय होईल, तो राईटला शिफ्ट होईल, म्हणजेच हे जे बिट्स आहेत पहिले इकडचे ते राईटला येतील, राईट मोस्ट पोझिशनला इकडे, आणि लेफ्ट पोझिशनचे जे वेकंट बिट्स झालेत तिथे 0 ऍड. दिस इज अ SRL operation. Okay, with the 2 bits, SRL2. Okay, now SLA म्हटलं तर काय होणार आहे तिथे की अरिथमेटिक ऑपरेशन होणार आहे, म्हणजे मी जेव्हा SLA2 म्हटलं तर तिथे काय होणार आहे की तो लेफ्टला शिफ्ट होईल, म्हणजेच 1 0 1 0 1 0 1 0 हे बिट्स असतील, पण राईट मोस्ट पोझिशनला जो बिट असेल तो इथे ऍड होईल, वेकंट पोझिशन. ठीक आहे, आता जर इथे 1 असता तर इथले बिट्स हे 1 झाले असते. ठीक आहे, आता इथे 0 आहे म्हणून हे वेकंट झालेल्या पोझिशनला 0 0 आलं. ठीक आहे, सिमिलरली आता इथे जेव्हा तो SRA म्हणतो तेव्हा 1010 हे बिट्स आहेत, हे पहिले 4 ते बिट्स राईट साईडला शिफ्ट होतील. पण आता इथे जे वेकंट झालं तिथे काय फील होणार आहे, त्या वेकंट पोझिशनला राईट मोस्टला लेफ्ट मोस्टला जो कुठला बिट होता तो होणार आहे, म्हणजेच इथे 11. ओके, तर युअर रिझल्ट विल बी 111010. ओके, अँड रोटेट साठी काय होणार आहे, फक्त हे नंबर्स जेवढे बिट्स ते तुम्ही मेन्शन केलं तेवढे राईट किंवा लेफ्टला रोटेट होतील. ओके, सो दिस इज द shift operators which are used in a VHDL. Okay, so this logical operators, relational operators that we have seen. Now let us go towards the operands. Now whenever we are using any expression, that times we need to use operands. Okay, so we want to compute value or we want to relate certain that operand. So for each of these purpose we need to use operands. So these operands that can be that are themselves as a expressions. Okay, so that means these operands, they may be expressions or you can just take a particular variable. Okay, so that is also that it can be used as a operand. So operands is an expression that includes literals, then identifiers, then index names, slice names, attribute names, aggregates, qualified expression, function calls, and type conversion. Okay, so these are the different types of operands that we have discussed actually earlier. So this is the list of these literals. So literals, that means constants actually, and that can be classified into two types, two groups. Okay, so one is the scalar type and another one that is the array type. So scalar type, that means character bit, then std underscore logic, then boolean, real integer or time. All these could be taken as a scalar type. And then array type, that is a string, then bit vector or std underscore logic vector. These are the array types. ओके, म्हणजे तुम्ही कुठलंही ऑपरँड घेतलं जे तुम्ही मेन्शन करता, तुमच्या सपोज तुम्ही एंटिटी मध्ये मेन्शन केला दॅट इफ इट इज अ स्केलर टाइप और अरे टाइप, दॅट यू कॅन टेक इट ॲज अ ऑपरँड. ओके, तुम्ही जे कुठले पिन असाइन करताय, कुठलाही सिग्नल असाइन करताय, तर त्याच्यासाठी जे तुम्ही लिटरल वापरताय किंवा कॉन्स्टंट वापरताय, तर ते तुम्ही ॲज अ ऑपरँड म्हणून यूज करू शकता. Okay, then the another type of operand, that is a integer identifiers. Okay, so identifier, that is a simple name. It is name for a constant or a variable or a signal or an entity, a code, subprogram and parameter declaration. Okay, so this identifier, whatever name we are given to particular constant or whatever we want to declare it in our program, so that can be used as a identifier. Okay, a name must be given. Okay, so now whenever name is given to all this, we need to remember that it should start with the alphabetic letter which is followed by letters, then underscores or digits. Okay, so we cannot use any another special character in a identifier. We have to just use a single special character, that is an underscore. Okay, but again whenever we are using this, we need to remember that this underscore cannot be the last character. Okay, तुमचं लास्ट कॅरेक्टर हे तुमचं डिजिट असू शकतो किंवा लेटर असू शकतो, अल्फाबेट असू शकतं, म्हणजे पण दुसरं कुठलंही तुमचं तिथे म्हणजे स्पेशल कॅरेक्टर तिकडे असू शकत. ओके, सो देर आर सम रिझर्व्ड वर्ड्स in a VHDL. So we cannot use that as a identifier. Okay, this VHDL identifiers that are not case sensitive. Okay, so always remember this, that these are not case sensitive. म्हणजे तुम्ही आधी जर मेन्शन केलं असेल की S, capital S and 1. Okay, so in a last practical only we have seen this. We have mentioned S and 1, S1 with a capital S and 1. So when if suppose in a program, if I write it in a way that small s and 1, so that will not give us the error. It is allowed in a VHDL. we can write in any case whatever operands that we are using or the identifiers that we are using in a program. Okay, so that means actually here the example is given, that is xyz is equal to small xyz, that is a lowercase xyz is equal to lowercase x, then capital Y and Z, which is same as that of the capital XYZ, or it is equal to capital X, then small y and capital Z. However you want to write, that is okay. त्याने काही फरक पडणार नाहीये, तुमचं जे काही रिझल्ट आहे तो सेमच येणार आहे. Okay, so that is the identifiers. Then index name, so an index name that identifies one element of an array object. Okay, so the syntax is array name and then expression. Okay, so with that you can have a indexed value there. So when array name is the name of, where array name is the name of the constant or variable of an array type, and the expression must return value within the array's index range. Okay, so type column is of range 1 to 80. Then the type row, that is in the range of 1 to 24, and type matrix is an array of row column of boolean. So that means here this is the range for the column, that suppose we have certain columns, okay, in the range of 1 to 80, and then row that is in the range of 1 to 24. So we can have the matrix which is the array of row comma column. So that means the matrix will be whatever is the range of this. So it will have the range rows, that is a 1 to 24 rows and 80 columns, 1 to 80 columns. Okay, so that is then S11. So that is the that is nothing but the first row and uh, first column element. Okay, so S1 comma 1, that means it is a first row, first column element, and S3 comma 14, that means it is the element at of the third row and 14 column. Okay, so in this way you can get the indexed value. So where we are using the index name as an identity. Then slice names and aliases. So that is slice names, that means it identifies a sequence of elements of the array object and the direction that must be consistent with the direction of the identifiers array type. And alias creates a new name for all or part of the range of the array object. Okay, so again you must have seen this. Okay, alias we used where we wanted to use some part of the actual element when we have written the code for shift add shift multiplier. Okay, so there we wanted the least significant bit of that addition, so or that accumulator. Okay, accumulators least significant bit we want to check whether it is a 0 or 1. So in that case we used a alias. Okay, so that means it will give us a name or it will create a new name for the part of the array. Okay, so here you can see the examples of this slice names and alias. Okay, so already we have discussed this in a earlier session, so I am not more focusing on this, but if you have any doubt you can interrupt me in between and you can ask doubt. Okay, तुम्हाला जर काही डाऊट असेल तर तुम्ही मध्येच मला थांबवू शकता आणि तुम्ही विचारू शकता, काही प्रॉब्लेम नाहीये. So just check if you are not understanding any of the part, or तुम्हाला आधी नसेल लक्षात आलं नसेल कळलं नाहीये असं काही असेल तर तुम्ही मध्येच मला थांबवा, तिथे विचारा, and then we will proceed. Okay, so these are the attributes names. So attribute takes a variable or a signal of a given type and it returns a value. So the commonly used attributes that are left, so it returns the left index of the leftmost element of the data type. Then right, it returns to the index of the rightmost element of the data type. Then high, which means high, it will return to the index of the highest element. Low, that means it will return to the index of the lowest element. Then range, it will determine the range. Reverse range, that means it determines the index reverse range. Length, it returns to the number of elements of a bit vector, and event that means it returns represents whether there is a change in the signal value at the current simulation time. Okay. So here, whenever we are considering the attribute name, so how to represent it, that we will see. So here, suppose we want, we have a certain vector, okay, or an array. So here we have an array that is a A1, which is a bit vector, which is having a 10 down to 0. So now when we are representing an attribute name, so that time we need to represent it in this way. So A1 apostrophe left. Okay. So that means it will return to the left value. Okay. So it is a 10. Then A1 apostrophe right, that means it returns to the rightmost value. So that is a 0. So A1 apostrophe high, that means it will return to 10. A1 apostrophe low, that means it will return to 0. Then A1 apostrophe range, that means it returns to the 10 down to 0. So it will give us the range. Then A1 reverse range, that apostrophe reverse range, that means it returns to 0 to 10. And A1 apostrophe length, that means it returns to 11 because it is a 11-bit array. Okay. Then aggregates, that means it can be used to assign values to an object of array type or record type during the initial declaration or in a assignment statement. Okay. So here, suppose we have the type color list, that is red, orange, blue, and white. Then type color array is an array of a color list of bit vector 1 down to 0, and variable x that will be assigned to color array. Okay. So x could be assigned to 0, 0, 0, 1, 1, 0, 1, 1. So red, that means it is a equal to or greater than 0, 0, blue that is a 0, 1, ray, orange that is a 1, 0, and white 1, 1. So in the second line, we defined an array whose element number, that is the index range, is given by a color list. Since color list includes 4 elements, so color array type also includes 4 elements, all of which are bit vector. Okay. Instead of color list, we may use a range that is a 0 to 3, because this definition only defines the range, not the element type. So here we can have a range that is a 0 to 3 also. That means we can use the integers also. So that will represent 0, 1, 2, and 3. Okay. So that is the aggregates. Okay, similar type of things that we have done in while doing for the state machine program. Okay, so sequence, in a sequence detector we can use in this way. Actually, we use the states in the same way, that is a 0, 0, 0, 1, 1, 0, and 1, 1. Okay, so we used a bit vector there, and depending on that, this x will have these values. Okay, म्हणजे आपण तिथे काय केलं होतं की स्टेट्स केले आणि मग 0 to 0, 0 to 0. Actually, that vector that we assigned as a 3 down to 0, that means that will have the values from 0, 0 to 1, 1. Okay, so in that way, similar way we are doing here. Then qualified expressions, that are that states the type of the operand. So type, name, apostrophe, expression, that will give us the type of that operand. So here type now when it is required, whenever we are having different two types. Okay, so in which suppose now here you can see in this example, red color is present in both of the operands. So in that case, we need to mention that or identify that in from which type we are considering. Okay, so here color to apostrophe red, so that means it will be indicating operand from this color to. Now, sometimes it is happening that the types are not of same type. Okay, so we can use the type convergence there. Also, type conversion that provides for explicit conversion between closely related types. Okay, so that means suppose we are having the expression that is which is having a type that is a std underscore logic underscore vector. So that we can convert into another type that is a std logic. Okay, so for that actually here we have the this x and y, these are of different types. Okay, and that is not allowed in a VHDL, but we can convert this x into the same type of that of a y, that is a std underscore u underscore logic vector. Okay, and then we can relate it. Okay, so that is the type conversion, but this can be this could be done only if they are closely related type, then only we can do this, otherwise it will not be possible. For if suppose you are considering x is of the type bit, okay, and y is of the type std underscore logic underscore bit vector. Okay, so in that case it will not be possible because one is the vector and another one is the bit. Okay, so in that case it is not possible, but if both are the vector which is, then you can convert it into another type. So then the next sequential statements, that is the another part. Okay, so we will discuss about this in the next session. So till then, if you have any doubt, you can ask me. Otherwise, I will just call your roll call, because now I can see when this lecture was started, I can see more than almost 47 students they joined this session, but now only 42 are there. Okay, so I'll just call a roll call. Roll number one. Roll number one. पायल. ओके, मोबाईल कुठे ठेवला? पायल कुठे आहे? So roll number one. Two. Roll number two is there. Three.
Present, madam.
Four.
Present, ma'am.
Five.
Present.
Six.
Yes, ma'am.
Seven.
Present, ma'am.
Eight.
Present, ma'am.
Nine.
Present.
10.
Present, ma'am.
11.
Present.
12. 13. 13.
Present.
14.
Present, ma'am.
14. 15.
Present. Present, ma'am.
16.
Present, ma'am.
17. 18. 18. Pallavi. 19. 20.
Yes, ma'am.
Who's this? Pallavi.
Yes, ma'am.
Okay, 19.
Present, ma'am.
20.
Present.
30. Oh, sorry, 21. 21. 22.
Present.
23.
Present.
24.
Present, ma'am.
25.
Present, ma'am.
26.
Present, ma'am.
26. 27.
Present, ma'am.
28.
Present, ma'am.
29,
Present, ma'am.
30,
Present.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34, 34, Sushma, are you there? 35,
Present.
35, 36,
Present, ma'am. Present, ma'am.
37, 38, 39, 37, 38, 39, 40, Kaustubh, 41, 42,
Present.
43, 44,
Present.
45, 45, 46, 47, 48, 48, 49,
Present, ma'am.
50, Sunil, 51, 52,
Present, ma'am.
53, 54, 55, 56, 57,
Yes, ma'am.
58, 58, 59, 60,
Present.
61, 61, 62, 63,
Yes, ma'am.
64, 65, 65, Prathamesh, 66, 67,
Present, ma'am.
68, Arpita, 69,
Yes, ma'am.
okay. So for today's lecture, 30 students are absent. Okay. Just tell your friends to attend these sessions sincerely. Okay. So you can leave for today. We will meet in the next session once again with this revision. ओके, तोपर्यंत कुणाला काही डाऊट असतील तर तुमचे डाऊट्स घेऊन या. म्हणजे मी परत परत तेच बोलण्यापेक्षा तुम्ही नवीन काही घेऊन आलात तर त्याच्यावरती आपल्याला बोलता येईल. ठीक आहे. So let us discuss about this basics of VHDL in the next session once again. So till today, till then, for this session you can leave now.